the homework. So we're looking at homework 3. Okay, so we are looking at... Okay, so we're just going to go through the whole thing, okay? We're doing homework 3, number 2. Oh, and I do have a special visitor. Come here, Momo. Come here. Come here. She's going to get off the couch. Let's see. Yes, there we go. Come say hi. Look, there's treats. You don't have to sit for these. Come here. Okay, fine. We'll just do this. Yay. There's Momo. Good girl. Lazy bum. You want to go back on the couch? Okay, go on. Go back on the couch. Okay. Cool. So, now she's waiting by the door. She's like, I don't want to be here. Cool. Okay, so, missed the answer. No, we are not covering new stuff, Zoe. Yes. She is the laziest of my dogs, that one. Her name is Momo. She is an Akita, and she just wants to go downstairs and go on her own couch, because my couch is not good enough for her. So, okay, come on. Come on, Momo. Come on. Okay, there we go. Okay, so... So she's also my biggest dog, so, and the only female. The other 8 are all males. Okay, so she's, like, kind of in control. Okay, so looking at number 2, we have something that is 20.78% potassium, 53% carbon, and then 2.678% hydrogen, and then 51.02% oxygen. Okay, so looking at these, do we remember how to start empirical formula problems? Yeah. Magic of erasable stuff. These are all grams now. Yeah, so we want to go ahead and figure out the moles. Potassium is 39.10. Etc. Okay. I'm assuming you guys have done this calculation for me already. So, what did you guys get for this when you did it? Okay. Did you lie to me? I should have known. 5, 3, 1, 5. Okay, whatever. That's fine. Okay, next. So I do have 2 prior exams, Marissa, that are on Canvas. You can check those out. One of them is multiple choice and the other is like fill-in, so you can try both of them, and the keys are also available, so you can take a look at your answers. And those should be, just so you guys see, I'll just move this over. We'll didn't need to gigantify it. Okay, so that should be just on your regular front page. You should see like exam 2. This one was from fall 2018, and then there's the key, and then there's the spring exam 2 and the key for that one. So they're just at the bottom of like our main homepage. Okay, so those should be there for you guys to have a look at. Thank you, Cassidy. 2.6573.189. Okay. Okay, and then so remember now we're going to divide these all by smallest one. Okay. And so we should get, it's like 1, probably 4, 5, and 6. Just eyeballing it. Okay, cool. So that tells us that we have K, C4, H5, O6. Not really, Melissa. You should get, I mean, it'll be like 5.9 or something, or like 6.01. You know, so you'll still see it's 6. Okay, great. So, we're also given in the problem, wherever it went, that the real molecular or molar mass, was 564.51. We're doing problem number 2 on homework 3. Okay, so so what do we want to do in order to go from our empirical formula to the molecular formula? What do we have to do next? Exactly. So let's go ahead and calculate that empirical molar mass. Okay, which is going to be, time to look it up. Yeah, 188.177. Yeah, you're very good. Okay, so we should get 188.177 or something like that. 176, whatever, good enough. 18, whatever, it's fine. So we now want to do 564.51 divided by 188.177, which eyeballing looks like 3. Okay, cool. So that means we have to take our empirical formula, multiply everything by 3, so we should get 018. And so that should be our answer. And yeah, Tiffany, so technically this first one is potassium bitartrate. It's a real compound, but I wanted to give you guys a practice to use the thing, so I just made this up. So I just multiplied it by 3. So yeah, it probably doesn't exist, but whatever. Yeah, good. So happy face, we have completed that problem. And then just so we remember, this was the real molar mass divided by the empirical molar mass. Okay? And that's how we got there. So, if you have other questions or more questions on this problem, okay, we can do number 6. Same homework, I assume? Okay. Whoops. Yeah. This should not be too bad. So yeah, Samville had emailed me reminding me that I didn't talk about metallic character. Whoops. So since some of you guys are still here, you get to learn about metallic character. It's the same trend as size. No, Marissa, since we haven't gone over that yet. Yeah, that's a good way to do it, Elsa. So, that would definitely work. So, I assume that's one of the questions. Then electronegativity is the same trend as electron affinity. So, those two should be, like, basically it's just adding more stuff that you guys already know. So, let's do it. Okay, so 6A asks us to do the largest. Okay, that's fine. Oh, yeah. So we'll talk about the covalence and nonpolar stuff next time. So, since I did naming first before talking about bonds. So, yeah. Okay, cool. So the largest. Oh God, that's really ugly, isn't it? Here, we could fix that. Largest. Okay. Where on the periodic table is the largest element? Yeah, bottom left, right? So down and to the left. So we're going to try and find from all those elements in question 5, we want to see which one is the furthest down and furthest to the left. Okay, and so which one did we find for that? Okay, that seems reasonable. Cesium, yeah, cesium makes sense. I would agree with that. Okay. Did anybody have any problems with that one? So again, we're just finding which one is furthest to the left and furthest down. Okay, great. So then for part B, we're asked for the least electronegative. We can interpret that also as least electron affinity. Francium is the largest, Robert. You're correct. But we're only looking at the elements given in number 5. And francium's not on that list. Okay, so least electronegative is again going to be cesium. Yeah. For sure. Okay, highest ionization energy. Is fluorine on the list yet? So, yeah, I agree. So remember, when we're looking at ionization energy, we're going up and to the right. And so, we're going to have fluorine. Okay, and then the last one is least metallic, which I will tell you now is the same thing as the smallest. Okay, so least metallic is also the same as saying the smallest. Okay, these two are going to be exactly the same. And so, just like before, oops, that's the wrong blue, we're looking at fluorine again. Okay, so who cares about the rest of the elements? All this is about cesium and fluorine. Okay. Last two problems on experiment 5. Oh, that would be the lab stuff. I do not have a copy of the lab manual. So I am not sure how I can help with those. Well, I mean, I have one, but it's not at home. It would be on campus. So, yes. In the meantime, let's see if there's other questions that maybe I could answer. Unless, you happen to know the problems. Yes, we can do that, Marissa. Okay, cool. So, if let's say we had a question. So Cassidy, if you can find like the question, you're welcome to post it, and then we can go over that. But I do not have it on hand. Okay. Oh, okay, we can do that. Cool. Yeah, we can definitely do that particular question. So, but in the meantime, let's make this horribly nasty for you guys. Just because, let's see, mass of Ag in 3.62 grams of silver acetate monohydrate. Look at how nasty I am. Okay, so this particular problem will hit on at least 2 different areas that we've talked about, so that should be nice for us to review these. So let's take a look. How on earth are we going to start this problem? Yeah, so we're going to need the molar mass, but first, technically, we're going to need the formula, right? We should also translate this into the formula. And then, yes, let's find the molar mass. Cassidy has written question 6 for the lab. This one is just kind of one I made up in order to answer Marissa's question. So we're going to do number 6 after. Okay, so once someone has it, go ahead and type out your answer. Anybody calculated the molar mass yet? Seems reasonable. Okay. Let's go ahead and assume you're correct. So one of you is lying, but which one is it? Is it 183 or 184? I don't actually know the answer, so... Aha! Okay, very good. So 184.932 or something. something around there. It's okay if it's slightly off, you know, because again, multiple choice means that presumably the answers will not be so close that it would be hard to figure out. So, in order to do the mass percent of silver, we're going to have to do silver over the molar mass, which is equal to, silver is 107.9 over 184.932, comes 100%, which is equal to cool. Great. Oh man, why do you guys keep getting slightly different answers? Alright, I'll do it myself. Very well. 107.9 divided by 184.932. Oops. Okay, I got their answer, Marissa, so something's gone wrong on your end. So, once we know that we have that silver is 58.35%, we can take the number we're given, the 3.62, and we know that 58.35% of that is silver. And so, we can see the answer that way. So here's Gumbo again. Do we remember Gumbo? Gumbo is the little piggy. All he cares about is food. And he's here looking on my desk. No, he is not the scared one. He thinks the camera is food. Once he realizes I don't have food, he will abandon me. So he just periodically wanders the house room by room looking for food, and then he goes to sleep on my bed, and then he goes back to looking for food. So that is his day. So, so actually this one we adopted from Pasadena Humane Society. His name was Guero, to begin with, but I like funner names, so I made it Gumbo. Yes. Though I had done that before I realized what a little piggy he is. So, alright, he's ready to go down to... Oh no, he's found my pocket. There's treats in there. And now he goes. Okay. Hi, Gumbo. Go find food. They're working on their homework. Or rather, mass percents. Why has nobody done this problem yet? Alright, fine. He can have a piece of this treat. Here you go, Gumbo. Fair enough. You guys are well prepared with your excuses this time. That seems pretty reasonable. Okay, we can do those, Cassidy. So Melissa, one thing you want to do is remember percents. If you're going to do a calculation with those, we really want to put this in our calculator as a decimal. Right, so technically you guys have the right number, but it's just multiplied by 100. So So it's going to be 2.11 grams. Okay? Otherwise, we'd be rich. 211 grams of silver coming out of this. We'd be so rich. Yeah, so cool. Okay, so that is how we found the amount of silver in grams of a particular mass of a particular silver-containing compound. So first we found the mass percent, and then we multiplied that percent times our total mass, and that's how we figured out the mass of that particular element. Okay? Any questions on that before we move on to numbers 6 and 7 on the lab? Well, we'll see. He just happened to waddle in here looking for food, so we'll see if anyone else shows up. We'll see. Maybe the creature will make a surprise visit and scare all of you away. But we'll see. I cannot predict the future. So, cool. Okay, let me scroll up for number 6. Okay. Okay. So we're looking for the mass of one gold atom in milligrams. So we're going from atoms to milligrams. So just setting up our unit conversions. What do we have to go in between to go from atoms to milligrams? What's kind of the unit they're going to have in common in terms of conversion factors that we know? Moles, yes, but I think grams is going to be easier to work with. We could go to moles, but that's just going to be an extra step. Okay, because we remember that we have a conversion factor from atoms to grams, right? We have the AMU is the same thing as grams per mole, which is the same thing as grams over 6.022 times 10 to the 23rd atoms, right? So we could use the mole one, but there's really no need. We should use this one instead. Okay, and so we want to see that it's gold, right? So what is going to be our mass that we're going to use? Come on, what's gold's atomic mass? Go, go, go. Thank you. 196.7. Or whatever. 19. Let's just, yeah, that's fine. Okay. That's the amount. We got this from the periodic table, right? That's the atomic mass, okay? So, let's use green, because why not? So we're going to go from one atom of gold. Which one's going to go on top and which one's going to go on bottom here? Are we going to put grams on top or atoms on top? I think grams should go on top because we want atoms to cancel out. So we're going to want to put atoms underneath so that they will cancel out. We want those guys to cancel out, right? So, by the way, if anybody can't see any of these colors, just let me know. I'm going to keep using them until someone tells me not to do so. Okay, so we have our conversion factors, which we got from the periodic table. Right? Okay, and so now from milligrams to grams, I've given you the conversion factor, but of course you should know that one. Which one is going to go on top? Milligrams, right. And so we know we have this, or whatever your particular way of doing grams to milligrams is. If you put 1,000 on the top, that's okay too. Whatever way you like to do it. Okay? And then from this, we'll get some answer that should be really small, because one atom should weigh a very small amount, right? Oops. Okay, anybody have the answer for this one? I can do it. Yes, it should be recorded. Okay, so yeah, you've got it's going to be 3.27, but we also have 8 times 10 to the, right? Yeah, it's going to be 10 to the negative 19. Gumbo's back, everyone. Let's see. Oh gosh. Okay, here he is. Let him sniff around for a bit. Okay. So, yeah, this is Gumbo. You can tell because he's sniffing instead of cowering in fear. That was just how we're converting between grams and milligrams. Oh, don't change the screen, sweetheart. Okay, let me take him off because he's missing. You can do that. Okay. Let me, I got negative 19, so, let's see. Okay, even if you're using 1,000, whichever one, Cassidy, you should still get 10 to the negative 19. We can see here that these two should be 10 to the 20th, right? Like those two, if we just put those two together, we'll get that. And we know that this one is really like 10 squared. And so, like, if we're seeing 10 squared over 10 to the 20th, that's 10 to the negative 18th, which is going to be a lot closer than 10 to the 27th, right? So make sure that if you are going to put in your calculator as times 10 to the 23rd, you're going to need parentheses around the whole Avogadro's number. Okay, otherwise it's going to put 23rd on top, and that's going to give you the extra. Okay, so make sure you put parentheses around your Avogadro's number, or use that E button. EE button. Okay, because you should get negative 19. Yeah, the calculators can suck sometimes. So that's why it's important that we always, even if someone else has given us the answer, it's always a good idea to work through it on your calculator so that you can input it correctly. Okay, great. So hopefully parentheses helped, or using the EE button. Okay, so let me look at number 7. Then we scroll up for that. Okay, so we are given 37.5 carbon, 58.3 oxygen, 4.2 hydrogen. Okay. Oh. Well, like I said, Samville, don't worry about your lab grades. We'll figure that out at the end of the semester. So I understand that is very frustrating for you guys. So If I have any sort of short answer stuff on the exam, I'm gonna not have any crazy scientific notation or, terribly strict rounding rules. So, okay. So, I'm just gonna go ahead and assume that we've already converted these to moles. What did we get for this one? This is number 7, I think, on the lab manual for that experiment. I think it's 5, she said. Yeah. Okay. And then the last one. Oops. Okay. Oh, okay. So you already I think, Cassie, you've already gone ahead and that's a 7. You've gone ahead and divided by the smallest one, right? So, okay. That's okay, Cassidy. So if we do that, apparently we're getting 1.17, 1.35, and 1, right? Totally cool. So, we're going to just let's try multiplying by random numbers to see if we can't get this. Right. So always the first number, if you have no idea, you should always just try 2. That'll usually help out somewhat. So if we try multiplying these by 2, we'll get 2, 2.34, and 2.70. Yeah, you are going to multiply by 6, but we can go through there. So 2 didn't work. You can try 3, try 4, try 5. And if you get 6, you're going to see that if you do 6, you should get 6, 7, and 8 in nice numbers. So just try multiplying by integers until you get integers. That's fun. Yeah, so in this case it's going to be 6 that we're going to have to go with. Another way we could look at this is if we see 1.17, if you remember your fractions, 1/2 equals 0.5, 1/3 is 0.33, 1/4 is 0.25, 1/5 is 0.2, and 1/6 is 0.16, never ending, right? So we're going to see here that if this one is 1.16, if we multiply it by 6, it should round out. So if you see these kind of fractions, you should multiply by the reciprocals to get rid of them. If you see anything with the 0.5, multiplying it by 2 would get rid of it, right? If you see anything with a 0.33, multiplying by 3 should get rid of it. And then, and so on. So typically you're not going to go, past 8, I would say. 8 would be, already kind of the craziest. And that would be the farthest you would go. Okay, so you should get, for this one, 6, 7, and 8. Alright, so C6O7H8. It's a weird way to organize it, but yeah. Normally you do hydrogen second. Alrighty. Any other questions? So I would remind you, go ahead and try the practice tests. The keys are there, so you should be able to see your answers. Hopefully there's no mistakes on them, but I am a human too, so that might happen. And yeah, I will be available, of course, before class next week. And yeah, so let's have a look at our poll and see who has won. Okay, there's the worms, so we're going to take a Canvas exam. So you will go on Canvas right at 3:30. So I'll send out an email with directions for what to do. So you will not need to go on Discord that day. I would say approximately 30, give or take a couple, just depending, because I have not written it yet. That is correct. You will not see me again until 2 weeks from now. Something to tide you over. I can post pictures for you guys, don't worry. It seems that everybody's having issues with the lab, Kimberly. Again, sorry, I'm unfortunately not your lab instructor, so... I don't know, Sarkis. We'll deal with that, come closer to the end of the course. Yeah, so usually what happens is the lab instructor will email the scores to the lecture instructor, and then I would take those and put it into Canvas or something. Yeah. Like I said, don't kill yourselves over the lab. So I understand that formatting is your bane of your existence, and you have to do twice as much work to even just put in your answers and then get it wrong because you typed the period wrong or whatever. I hate that. So, yeah. But on a good note, if you want an opportunity to air your grievances in that manner, I have been given permission to interview you guys and survey you based on your experiences with your online stuff. I mean, I just want to collect data and see what you guys are thinking about stuff. So I'll post information about interviews and surveys and stuff later. That would be for extra credit and stuff. So, but that'll be again towards the end of the semester. Okay, so I'm gonna go ahead and stop the video because